Happy New Year, everyone! In this video, I'll show you the ESP8266 toy, which I designed a few weeks ago. You've probably already heard about the ESP8266. It's a very low-cost and compact Wi-Fi module that has become extremely popular recently. At the basic level, it's a serial to Wi-Fi module, which allows any microcontroller such as the Arduino to have Wi-Fi capabilities through serial communications. And with some of the recent development, especially since the manufacturer has released the SDK source code, you can actually customize the firmware and perform a lot of computations on the module itself. So the ESP8266 toy, or ESPToy for short, is an Arduino-compatible battery-powered gadget for easy prototyping with this Wi-Fi module. You can use it to make a standalone Wi-Fi enabled project. It has a built-in ATmega644 microcontroller, a USB serial chip and a mini USB port, a 3.3 volt linear regulator, a color LED, push button, light sensor, temperature sensor, and lithium battery jack. The Wi-Fi module can be directly plugged in here through this pin header. And there are additional analog and digital pins here at the bottom for prototyping. The microcontroller runs at 16 megahertz and it comes with the Arduino bootloader. You can program it directly through the USB port here. Once programmed, it can run on an external lithium battery or a 3 volt AA or AAA battery pack. There is also a power MOSFET on the board, which you can use to programmably control the power supplied to the Wi-Fi module. This is useful if you want to power off the module to save battery life. To communicate with the Wi-Fi module, the basic approach is to program the microcontroller to send the so-called AT commands to the module through the serial interface. And you can find plenty of online documents about these commands. So let me show you a few quick demos. The first is a demo that searches for the correct baud rate for the Wi-Fi module. Why do you want to do this? Well, in order to talk to the Wi-Fi module, you need to know the correct baud rate. Often I get confused what baud rate the module came with, and some of the newer ones allow you to change the baud rate. So it's better to have a way to automatically detect the baud rate. The program is very simple. It basically loops over the common baud rates, sends an empty AT command to the module, and checks the result. If the result is recognizable, then that must be the correct baud rate. So let's try this. So first I'll plug the ESP Wi-Fi module to the ESPToy, and then I plug in a mini USB cable. Now if you've set up the Arduino with the ESPToy library, then you will see the ESPToy as the board, and then also the serial port is CH341 USB. And then next you just upload this program to the ESPToy, and then we will open the serial monitor. So as you can see, it found that the correct baud rate for this particular module is 9600. So this is the one of the newer ones that comes with the 9600 baud rate. And then next I can plug in a different one. And so let's try this again. And as you can see, it found that the correct baud rate for this one is 15,200. So the second demo is the serial AT command, which allows you to send the AT commands to the Wi-Fi module through a serial monitor. Now, the ATmega644 microcontroller has two serial interfaces. One is wired to the USB serial chip, and the other is dedicated to the Wi-Fi module. So this program just basically passes the data received from one serial interface to the other and vice versa. So with this demo, you can experiment with all the available AT commands of the module. Let me bring out a serial monitor here. And so by the way, when you're using Arduino's serial monitor, make sure you select the line ending to be both new line and carriage return. This is required by the AT commands. So I can now experiment with the commands like, so for example, AT plus GMR shows the firmware version. AT, so this shows me the current mode of the module. So this shows the IP address of the Wi-Fi module, and yeah. The third demo is called Scan Network. For this demo, I'm going to power the circuit with a lithium battery. And so basically what this program does is when it starts, it sets the Wi-Fi module to AP mode. And it will create a local Wi-Fi network. And once the AP mode is established, the green LED will light up. So you can take out your cell phone or a laptop, and you can see that there will be a network that's called ESP underscore something. So you can click on this and then connect to this network. Once this is connected, you can then bring out a web browser and type in the IP address 192.168.4.1, and this will bring out a web page which shows all the nearby networks that have been scanned by the Wi-Fi module, and then you can then type in the SSID, and you can then type in the SSID and the password of your target network, and click on Connect. So at this point, the program will reset the module in station mode. So you can see that the LED lights, it turns off. And then after about 10 seconds, it will redirect the page and show you the IP address of the module on the target network. So it's a pretty standard approach to get your Wi-Fi enabled gadget onto a target network. The next demo is a simple web server. So here the program serves a HTML web page, and it uses JSON and AJAX to periodically read back the analog pin values and display them onto the web page. So if you type in the client IP address of the module, you can see that it shows a web page, and it refreshes every few seconds to show you the current value of the analog pins. And because the first two analog pins, they are wired to the temperature sensor and the light sensor, so they actually respond to light or temperature changes. Also, there are three sliders here which you can use to set the color of the color LED on the ESPToy. So I can, slide these values, and then you can see that the color on the LED changes accordingly. And again, I'm powering the entire circuit with the lithium batteries. So this can be used as a Wi-Fi enabled color LED light. There is an additional demo which is the same web server, but it uses an external SD card connected to the ESPToy, so that you can use the SD card to serve bigger and multiple HTML web pages. So that's all about the ESPToy. To find out more, please visit the blog post link above, and the Arduino library and source code of this project is available on GitHub. Thanks for watching this video.